My name is Ronnie Chen, and I work as a data engineer at Slack in San Francisco. Slack is a workplace messaging tool, and I build data pipelines and infrastructure to enable data analysis for how people use Slack. But in addition to being a data engineer, I'm also a technical diver. And today, I'm here to talk to you about failures. What failures look like, how to prevent them, and how to stay safe. So, yeah, I'm a diver. And I first got into scuba diving because I wanted to see incredible things. Things that I wouldn't get access to on the land. The ocean is a wonderful world of strange creatures and new environments, and I wanted to explore all of them. You can meet aliens of all shapes and sizes, and I've been fortunate enough to interact with many animals up close. Really close. Now, listening to this, you might assume that I've always been comfortable in the water. But the truth of the matter is that the ocean used to make me really, really uncomfortable. My first childhood memory is actually being on a rowboat in a lake when I was about 2 years old. And I looked over the edge, and I saw a bit of seaweed, and I stood up, and I reached for it, and then I fell in, and there's nothing but darkness. So I've had a healthy fear of the water my entire life. Diving gave me a way to overcome that nervousness, and I was no longer dependent on the surface for my air. As long as I obeyed certain rules, I was free to explore. And to help myself become more comfortable as a diver, I pursued more and more training. First, I got my advanced certification, then rescue, and then technical training. In my first year of diving, I did about 200 dives. Before I knew it, I was getting certified to go on deeper and deeper dives and learning how to safely enter and explore shipwrecks far below the depths of what recreational scuba diving allows. And then I bought a rebreather. For those of you who don't know what that is, a rebreather is a device that purifies and recycles the air that you exhale. It's the same life support technologies that used in spacesuits. Using a rebreather, I was able to do even deeper and longer dives than I did before. At 100 meters down, or about 330 feet, you're at 10 atmospheres of pressure. If you start heading up immediately upon hitting the bottom, you'll still need to do about 20 to 25 minutes of decompression at various depths as you ascend before you can safely surface. That means that you can no longer rely on swimming to the surface as a means of safety if something goes wrong. In fact, that's one of the definitions of what technical diving is. It's diving that has additional challenges over and above what you see on a recreational dive or a fun dive. Longer dive times, deeper dives, having an overhead ceiling that prevents you from ascending, decompression restrictions that prevent you from escaping to the surface. Those are just some of the added complexities that you have to deal with. The gear that you have to use can include 6 or more tanks weighing over 90 kilograms or 200 pounds. That's a dramatic increase in the number of complicating factors that your life depends on in order to survive. Now, this is just a small sample of the things that can go wrong when you're diving on a rebreather. Hypoxia, hyperoxia, nitrogen narcosis, carbon dioxide buildup, oxygen sensor failure, deep tissue isobaric counterdiffusion, high pressure nervous syndrome, software failure from your rebreather itself, exhausting your carbon dioxide scrubber, carbon dioxide channeling from a poorly packed scrubber, carbon buildup causing a spark leading to an oxygen fire underwater, flooding of your breathing loop or circuitry, water mixing with the scrubbing agent to produce a toxic caustic soda that will give you chemical burns on your mouth, airways, and lungs, and just plain old decompression sickness. And all of this is just on top of the usual challenges you can face from going into an environment that is hostile to human life. And remember, you can't swim to the surface when you have a problem. So your survival depends on fixing it at depth. If you own a rebreather for 5 years, 2% of you are going to die on it. 1 person out of 50 in 5 years. This is an incredibly sobering statistic. I mean, there are many highly compelling reasons why people still continue to dive rebreathers. We're not going to cover them in this talk, but there's also ongoing work to make using them more reliable and to reduce the risk of injury or death. So these numbers will continue to go down. But if you're a diver facing these kinds of odds, it becomes really important to prevent failures from happening and to learn how to survive failures when they do happen so you don't become that 1 in 50. So what can you do? Well, you can make a dive plan and calculate resource usage, add in buffers for safety, run every dive with 2 independent sources of breathing gas, so if something goes wrong, you can bail out onto another system. You can test the functionality of your critical components with checklists, verify that your backups are functional. You run through scenarios with your team and you talk about contingency plans if something goes wrong. Make sure that everyone's on the same page. Plan your dive, dive your plan. All right, hold on a second. This is starting to sound like a talk about communication and process. Those of you who read the talk description carefully should have seen this coming. But you came here to hear cool stories about diving and underwater exploration. But what you're actually getting is this meandering meditation on best practices when dealing with complex systems instead. So before we continue, I have a very important content note. The guidelines that I'm about to give you have only been shown to work for life and death situations under the ocean. They have not been proven to work for tech. So, with that disclaimer out of the way, let's talk about how to survive in complex systems. The first thing that we need to talk about is how failures really happen. We tend to think that a failure happens because someone did something wrong. That is to say, there is a single solitary catalyst that causes a failure to happen. But that's a really harmful way to think about failure, because we have redundant systems. We create backups. When we're planning, we budget extra resources for anything that needs resource contention. We conduct operations as a team. In diving, just as in engineering, a single failure should not result in catastrophe. But accidents still happen. Your database backup that should save you if something happens to the production database has been silently failing, and you don't have the alerts to tell you. Or maybe you are creating the backups, but the files are so large that you can't restore them successfully, so they may as well not exist. Or there should be a way to manually edit the file and continue the restore, but you don't know how to do it, and the one engineer that would know didn't write it down, and he's on vacation. If you've been to a few postmortems, this is starting to sound painfully familiar. And that's because failures in complex systems are messy, and they rely on the interaction of many, many factors. Here we have an example of a failure cascade in diving. You have a rebreather malfunction, which you would have caught if you were testing your equipment. But you didn't, because it was working fine just the other day. Your backup tank had a leak and it's running low, but you didn't test that either, because that was working fine the other day. Your dive buddy is too far away, and she's not checking in with you. And you have a dive light that you use to get someone's attention from far away, but that's out of power. So in the excitement of all of this, you kick up some silt, and now you can't see anything, and now you're starting to get nervous. Your breathing rate goes up, and you breathe through the last of the air in that tank that is slowly leaking. So now you swim to the surface, and you still have a decompression obligation. I mean, this is really bad. This is take a helicopter ride to a decompression chamber bad. What you see here is a chain of small individual failures that combine to form a total system failure, because every single item on this list allowed the cascade to continue. A break in any of these steps would have stopped that cascade and prevented the situation from getting worse. Which means that in this example, there were at least 8 things that had to go wrong for that failure cascade to happen. Now, if you did a post-mortem and said, what went wrong on this dive? and you said, well, it was because the rebreather malfunctioned, and that's why the accident occurred, you would have gotten only 1 out of 8 issues, or 12% of the actual causes of this accident. So it's really important that when we talk about failure, we look at all of the factors that combine to make the failure possible. So this is our understanding of failure. This is our takeaway. Complex system failures don't happen because a single part of that system fails. They happen because all of the safety procedures that are supposed to protect you from simple system failure did not work. Okay? Not just what happened, but what did not happen to stop that cascade from continuing. So that brings us to the first fundamental rule of safety systems. When I talk about a safety system, I mean some process or feature that makes it harder for the undesirable action to continue. In diving, this would be an equipment check, some sort of guideline or protocol, like planning out your expected gas consumption and then adding a buffer in case of emergency. It doesn't matter to anyone that these checks or protocols are created if they're not used as part of your procedure. So if you have a safety system and you don't use it, it doesn't exist in any sort of meaningful way. Pretty obvious, right? There's a term that's used in aeronautics and catastrophe analysis called normalization of deviance. It's that natural human tendency, particularly in pressure circumstances, to take a safety shortcut and accept a lower standard of performance. What's the first thing that happens when you take a safety shortcut? The first time that you jump into the water without verifying that you had enough breathing gas because the shop hands you a tank and it should be full. Or the first time you wrote code for a new feature and you committed it without writing a test. Be honest, we've all done this, right? Probably nothing. So what did you learn from that example? How does that affect your judgment going forward? That experience reinforces the idea that that shortcut was okay, that you had a deadline, just this once, you're confident of your code, it's going to be fine, so you're more likely to do it again next time. Pretty soon, that shortcut is the way that you do it every single time. If you have a checklist, you start ignoring items, you start skipping items. I'm sure this is right, so I'll push it without getting a code review. Then you take another shortcut somewhere else. If this continues, though, the rules get ignored so often that your sense of acceptable risk starts getting skewed. Your judgment becomes unreliable. Eventually, your ability to detect risk burns out completely. And you also create pressure for everyone that you're working with to obey these degraded processes. And at this point, the only thing that is keeping you from failure is luck. And sooner or later, that luck is going to run out, and you're going to experience a catastrophic failure. So simple, right? Stop using your safety system, and you don't have one. But number 2, an untested safety system doesn't exist either. If you have a passive safety system that you rely on, and you don't test it, it doesn't really exist either. A configuration that used to work 6 months ago or a year ago may not be appropriate as the system evolves. Components in a complex system can drift into an unsafe state, even if they were safe at the time that it was implemented. If I have a computer that reads from my oxygen sensors that makes sure my breathing gas is set at an appropriate mix to sustain human life, I need to know that it's properly calibrated. If the calibration is set incorrectly, or it starts to drift over time, it might be a while before I detect that something's gone wrong. But once the mix is too low on oxygen, I could pass out. If it's too high on oxygen, I could have a seizure at 100 meters under the ocean. So when this happens, the component can no longer provide that safety functionality that it was created for, but it gives me the appearance of safety. It gives me that sense of security that it is being monitored, and that I'm okay to continue. You never want to see a status page that shows all green checks when the system's actually on fire around you. But we see that all the time. So that leaves us to this conclusion that unused or untested safety systems are more dangerous than not having one at all. If you know that you have no safety system to catch you if you fail, you're going to be more careful. You're going to check things more often. If you think that you have that backup, if you think that you have that security, you're going to take risks that you wouldn't take otherwise. How long could your backup system write corrupted files before you noticed? Has your failover system scaled up to handle the load if your primary system goes down? The absolute worst time to realize that your safety system has failed is when you're counting on it to stop a failure cascade. So you build it, and then you test it, but you have to keep testing it at intervals to make sure that it's still working and it's still appropriate for the system that you're working in now. Because complex systems evolve, they change. So test at regular intervals, and also the length of this interval should be determined not by how likely it is for that system to fail, but also how great the impact will be if it does fail. Which brings me to a quick side note about risk. We usually talk about risk as the likelihood that something will happen. But another way to look at risk is how great your regret will be if that thing does happen. If you're only evaluating risk based on the chance of it happening, you have to be prepared to experience that corresponding level of regret. So in diving, a failure that could result in loss of life would be anything that threatens the quality of my breathing gas if it fails. So those safety mechanisms are tested very frequently. I do it on every dive because that failure mode is unacceptable to me. But looking at your own system, what are the chances that someone's going to make a mistake while typing a command and shut down all of your servers at once, or drop your prod database? How bad is it going to be if that happens, though, even if it's a low chance? What can you do to stop that from happening? We know that that does happen. We know that outages come from that. Are we building systems to make that difficult to happen, impossible to happen? Are we building systems that can withstand that happening and still recover? Because if there's one thing that we know for sure, it's that failures are going to happen. Complex systems are chaotic. They're full of interdependencies. A single service going down can cause so many retries that requests that otherwise would be successful can't be processed. You can write a data blob that is so large that it can't be ingested by your messaging queue. So you write an error message instead that happens to contain that data blob into the same queue. As your system grows, it develops relationships and entanglements that interact in all kinds of ways that are difficult or even impossible to understand and predict. So what does that even mean, then, to have safety in a complex system? If we can't guarantee that failures won't happen, and if, in fact, one of the key characteristics of a complex system is that small failures are always happening, do we just give up and stop trying? We don't just throw our hands up in the air and say, it's impossible, I'll just go home. So what are we really talking about here? Well, we want to get into a state of failure management. This is what I promised you on the title slide. It took us 30 slides to get here, but now here we are. So failure management. It's kind of simple if you distill it down. In a complex system where small failures are always happening, and different factors have interdependencies that change and evolve and grow over time, safety is having a framework for redundancy and coupling it with the training and judgment to use it. That's the two halves that work together, the framework and the training and judgment to use it. Really easy to talk about, but really a lifetime to master. When you have both of these elements working together, you're not just reacting to a failure when it happens, you contain it and limit it and provide yourself a path where you can rescue yourself when bad things happen. You can recover from a failure and stop it before it creates a cascade that ends in a catastrophe. If you have gaps in your framework, or you can't use it to that full extent because you don't have that training or judgment, that's when you see those failure cascades that we talk about. That's when you iterate to fill in those gaps, to build your training, to refine your judgment, and try again. So let's go a little bit more in depth into this. Framework for redundancy. We can think of this as failure management for the systems that we're working with. Software systems, aeronautics, technical diving. At this level of abstraction, it doesn't really make a difference. First things first. If you absolutely can't live without it, you need a backup. These are the systems where the level of regret, if they fail, is too high. If this fails, that's the end of the story. So you carry extra air tanks. You make database backups. Really basic, but it's not a step that you can skip. If it's important, but it's not critical to survival or mission success, then you plan a way to work around it. And then you test that plan to make sure that it works. Having a graceful degradation of services is having a redundant pathway to success that takes into account the new state of the system. If your recommendation engine is broken, we don't want to deny you full service, we just maybe give you worse recommendations. That's okay. If your main production database goes down, that's a different story. So you also want to implement a process to make that transition from your primary system to your redundant system. I mean, these are all kind of parts of failure management that people tend to be pretty familiar with, especially if you've worked in anything related to ops or DevOps. If you have to support a system, you understand these things intuitively, even if you've never seen it written out. You examine your system to see what can break, and then you figure out what action to take when they do. Two other points that you want to really think about are trying to limit the impact that a single failure can have on your entire system. If you put limits on your system so that if one service goes down, that's the only thing that's unavailable, that makes it a little bit easier to manage, a little bit easier to think about. If one service going down causes some sort of cascade, causes retries, causes overflow, congests a buffer, starts taking up disk space, that one service going down creates a cascade that ruins your whole day. Number two is just make it easier to do the right thing. Or make it so that nothing happens instead of doing the dangerous things. As engineers, we really like having control. We like having power, even if we never use it. But we're all human, and we need limits to protect us from our own mistakes. So both of these tips reduce the amount of chaos in your system, the amount of excessive factors that just make it even harder to maintain a safe system. Easier to reason about, easier to build a framework around. And these are both gateways between your safety framework that you've built and your human systems. Because humans are hard. Computers are easy. Humans make mistakes. They're not deterministic. Humans get tired. They get distracted. They make decisions based on emotion. Their fingers slip and they type the wrong command. So our systems need to protect us from ourselves. And this is where all that training and judgment comes in. They provide the basis for failure management in our human systems. Because pressure makes people behave in really weird ways. Stress influences how effective we are at carrying out even really basic tasks. One of my first technical training drills, we had to combine a very standard situation where someone is out of air and comes to you for assistance with running a safety line. Two really simple tasks, right? Running a safety line, someone comes up to you, hand them your air. But having to do both at the same time, my air consumption doubled. My brain was completely overloaded because I had to think and remember to do everything. Person comes up to me, out of air. Okay, what do I do? Give them my regulator. But what's happening with my hand right now? Don't release the line. Wait, what am I breathing right now? Quick, put in my regulator. What's my buddy doing? Buddy's going one way. I'm still here. Now I'm tangled up in the line that I had, right? And as this is happening, my air gauge keeps ticking down because I'm stressed and things are happening. Practice this a few times, right? Repeat this so that it's all muscle memory. And then I'm running my line. Okay, no, out of air. Here's my regulator, put in my backup, everything okay? We're going this way, right? Instructor comes by, takes off my mask, I can't see anything, I can still keep going. As you get more proficient, as your muscle memory builds in, you can handle harder and harder tasks because my brain isn't focused on what do I need to do next? What's my hand doing? What's going on over here? These things are automatic, and my brain is free to make complex judgment decisions on what's the best way to go? What is our overall strategy? So when the pressure is on, when you're on call, when you're managing an outage, having that muscle memory frees up your brain to focus on making the important decisions, the judgment decisions, while the rest of you is just acting. So a strategy that we use a lot in dive training is having the least experienced person lead the dive. And this sounds really counterintuitive to a lot of people, right? If you are going on a life or death expedition down under the ocean, you want to be following the person who's been doing this for 5 years. You don't want to go if this is your first time, right? But what happens is the whole team prepares together. They all create the dive plan, we run the numbers, we talk about what we're going to do, but the person who's actually swimming in front, who's leading the mission, is the least experienced. This doesn't mean that my instructor is just sitting back and just letting me crash and burn, take us down the wrong path, but it does mean that they're sitting back and coaching and guiding until safety requires them to intervene. And in that meantime, I'm getting experience not just in the physical tasks that I have to do, but also in making judgment decisions. So if the whole team has a goal of ensuring that the expedition is a success, that means that they assist the least experienced person in their own success. And that just allows for guided, targeted training. As your confidence and experience level goes up, the future runs go more smoothly. You're building muscle memory. You can sort out what's important, what's not important, what you need to focus on to make relevant decisions when there is a crisis, right? A crisis should not be the first time that someone has to take command. If something happens, you want everyone to be able to do the basic tasks without having to think, okay, where do we keep the run book? What's in the run book? Does this documentation exist for the thing that I'm going to do? What does it say? Open up the terminal, go back. Am I typing it in right? All of this, right? You want to just say, okay, this is what I need to do. Pull up the terminal, I have the permissions, log in, it's done, boom. If you're a more experienced person, having an inexperienced person do lead and head these projects, head these operations, is a huge benefit to you as well, because then you are able to work as a command role without having to manage or personally run every single action. You can sleep a little bit easier because you're not going to be paged as often on call. You can see what parts of the system are confusing, what parts are prone to error, what parts are not properly hardened against mistakes, where you need more documentation. But also, if there is an incident, if there is a serious outage, if that failure cascade has started to happen, you don't need to be personally in charge of every single thing. You can delegate. You are the incident commander, and you can trust that those actions will be run effectively by these people because they've had the experience and the muscle memory. Letting the weakest person lead training operations or daily operations, deploys, minor outages, is one of the best ways to equalize experience levels among a team. It helps you build trust, improve team communication, and giving them the authority to make decisions and giving them feedback and support will fine-tune their judgment, which is the other half of that equation that we were talking about, training and judgment. So we talked about complex systems being constantly evolving. And the best weapon against failure that you have is that judgment. Training and rules are just a proxy for that. When you're new, when you're inexperienced, you rely on that training. You rely on what the rules are. But when you understand the reason behind it, you can make more nuanced decisions that can better fit your current circumstance. You can say, well, this is what we usually do, but this is why, in our particular situation, a different action would be better. It would be faster. It'd be more efficient. So building your judgment, getting that experience, is what allows your rules and frameworks to adapt as your environment changes. So if building judgment is so important, we're going to need a lot of tools to develop better judgment so that we can make better decisions. Postmortems. Most of you are probably doing postmortems already. If you've stuck with me this far, you know that if you focus on a single person or a single event for a postmortem, you're ignoring the bulk of the problem. You want to look at all of your safety framework and identify key places where the cascade could have been stopped but wasn't. How do you make those parts of the system more robust? So again, not just what happened to start the failure, but what did not happen to stop it. Your goal for every single postmortem is to harden your system against this type of failure so you never experience the exact same failure twice. Another really helpful tool is the pre-mortem. It's a postmortem for a failure that hasn't happened yet. You shouldn't have to wait for a failure to happen organically to start doing this kind of work. A pre-mortem is a really effective way to surface any doubts or concerns you have about a system that may not be functioning quite as safely as you would like it to be. Anticipating failure is how you catch those high regret, low probability failures. A pre-mortem doesn't have to be as formal as a post-mortem, but talking about potential failures also helps reinforce that safety mindset where you oppose the normalization of deviance and you start building judgment. So sit down and say, if this project is going to fail, what would be the most likely way for that to happen? What would be the most painful way for that to happen? How can we defend against that thing? And then you run a fire drill based off of that. Remember what I said earlier about test your safety systems or they don't exist? Running a fire drill allows you to prove that your plans, that your safety systems are functional. This is applied failure management, whereas what we've been talking about has been theoretical failure management. You want to build that muscle memory for when the real thing comes along. At the most basic level, this is just a drill, running through a plan, testing out your run book, and verifying that it does what you claim to do. That you make a backup, does it actually restore properly? But for more complexity, and this is kind of fun also, designate an arsonist on your team to create a failure, and then evaluate how your system responds to it and iterate from there. Do you actually have sufficient monitoring and alerting? If someone goes in and kills a core microservice or starts adding a huge amount of latency to certain endpoints, do you have the monitoring and alerting to tell you that that happened, or does someone need to tell you that it happened? Can your team diagnose the issues correctly once they see that something's gone wrong? Are your tools and documentation sufficient to resolve the issue? I definitely advise that you start this off on test environments before you start creating failures on prod. But at the most advanced level, that is what you want to do. Netflix and Google both implement this in various ways with Chaos Monkey, and Google also has research teams where they simulate large-scale outages and actually shut things down. And that really tells you, can we withstand this? If you're hosting on the cloud, can we withstand our provider having a major failure? Are we still going to be okay? And last in that list for building judgment, revisit your past decisions. When we look back on our actions, we tend to restrict it to a case where a failure has happened. So a postmortem. But it's also really important to visit a success, to see what key insights you had there that were helpful, and also to see where you actually were helped along with a good dose of luck, and doing it again would not have been so fortunate. This helps root out these safety shortcuts that you have lurking in your system that you might not be aware of. Sharing these decisions with other people that weren't involved also helps them understand how to make these decisions in the future. You swap stories with other divers to avoid becoming a statistic. You swap operation stories, deploy stories, outage stories, so that you know how to protect yourself, so you know how to prevent it from happening to you. Building that judgment to go with your training. One final thing that I want to talk about today is success. We've been talking so much about failures. This is a little bit of hope. In diving, the best rescue is the one that you don't have to do at all. The best incident response is when you don't have an incident. This is where all of your safety framework and training and judgment come together. First, you struggle and you need to be rescued. Then you learn how to do rescues. And at the most advanced level, you prevent rescues from becoming necessary. If your safety framework and the training and judgment of the people who are running it are advanced enough to not have failure cascades, to account for most of the major failures that you encounter, that is a success. But our culture has a tendency to reward heroic action, right? And that's usually based on a response to failure. Something went wrong, people came in, they stayed late, we ordered pizza, they did such a great job. But true success lies in a job done quietly and without incident, day in and day out. If your inclination is to reward those late nights that happened in response to a failure, what are you incentivizing in your system? Are you noticing the teams, the systems, the organizations that are working safely, that never have an outage, and everybody gets to go home at the end of the day? Rewarding that kind of success creates incentives to build stronger safety systems and safety frameworks and better judgment. If you're interested in learning more about normalization of deviance and complex systems and how they fail, here are some links to get started. I'll be sharing these on my Twitter account after this talk, or I'll leave this up for you to take a picture. Let's see. And okay. I hope that I gave you some concrete suggestions to make the work that you do less vulnerable to failure cascades. And with that, stay safe out there, everybody. Any questions? Yes?
So when you are simulating a failure,
Mm-hmm.
do you have a staging environment or do you test in production?
So the question is, when you are simulating a failure, do you do a staging environment or test in production? The ideal path that you want to do is first test each component, right? Make sure that without even having the failure in the first place, just test that this piece works, this script runs, this documentation is correct, these commands are the right commands, everybody has the right permissions, this backup restores. Number two is to do that simulation in a test environment. Run it. You don't even have to, you can just say, okay, on Friday, we're going to have a fire drill between the hours of 1 to 4. And at some point during that time, someone is going to instigate a failure. And they're not going to say what that failure is. and you're just going to monitor the system and see if someone notices. After 10 minutes, 15 minutes, if nobody's noticed, then your arsonist can send a message and say, hey, did anyone notice that this endpoint is now getting a different status message? Or has anyone noticed that this monitoring system is showing red and nobody has an alert for it? And then let your team intervene. Once you can successfully run fire drills without having failure cascades, that's the point when you can move it to production and see if it scales up to production. But you definitely want to do this in an incremental and thoughtful way, right? Don't go home today and start running failures on production. You're going to get into a lot of trouble. Yes?
When you were talking about putting upfront the unexpected people,
Mm-hmm.
how do the experts understand when they have to enter, when they need to help the people in front? Because, in my opinion, it's not easy to understand this limit where they need to try out and they need a little time to test something
Mm-hmm.
by their own,
Mm-hmm.
or they need someone to enter. I don't know if there are some rules.
So it's good to have a guideline in mind before you start. So before you do anything, before anybody touches a keyboard, you talk about what we're going to do. You make sure that you have the documentation and you have a plan, right? We're going to upgrade the version on this server, so we're going to do a shutdown. We're going to deploy. We're going to now start spinning up those boxes, right? Whatever it is, you know exactly what you're going to do, and you have an understanding of what that looks like and how long that's going to take. And then you start. Having them lead doesn't mean that you sit there and you stay silent. You can have ongoing conversation. If they have a question, you can answer that, right? It's a communication. The point is that not only are they typing the commands and running them so that they literally have that muscle memory, that their fingers know what to do, but also that they get the authority to do that, right? If you see them typing the wrong command, you can stop in and say, no, right? You don't have to let them trigger the failure. You can give advice. You can say, maybe this isn't a good idea. Or if they're having trouble, just say, give them 2 minutes to figure it out, to look up that documentation. But also in your own head, when you see that happening, that's a sign of something is missing, something happened, right? Either your explanation originally wasn't clear, and next time you know that this is something that is very tricky, or your documentation is not very good. And so this is also a signal to you as the person, who's more experienced, who's sitting back to say, where can we do better in explaining this and giving more practice? Sometimes it is just, they just need more times trying it, but that's also a sign for you of, okay, you know in your head that for the next outage, this person may not be comfortable, but the solution there is to give them more practice instead of saying, you can never touch that system, right? And so it's just a good guide of saying, have a plan for every single step, and you're here to answer questions. You have open communication always, but just give them a chance to do that, to talk them through it, and to explain what your reason is. If you say, okay, in this situation, this is what I would do, explaining why you do that, and having them be responsible for taking in the information can help. Because you can say, this is the information we have, this is important, this is why, this is not important, this is important. And the next time they're in that same situation, they understand how to make that decision, even if it's not the exact circumstances that you're in. Yes?
When you spend effort on protection,
Mm-hmm.
you're not spending effort on growth.
Yes.
So as a manager, you have to balance, to decide which is the balance between the two efforts.
Absolutely.
Do you have in Slack any rule or framework to decide how much to put in protection and defense and how much to put in growth and attack?
So this is where there's no hard rule that says, okay, 70%, 30%, or whatever it is. But what these guidelines that I have can tell you is if you run a very small outage and your team can handle that, right? Just say take 2 hours, 1 week, you run this outage, everything is great. That means, okay, maybe you can continue to spend more time on growth because your safety system is in a very good place. But if you think this is a very simple outage, I'm just going to drop, 20% of the packets that go to this host. Should be pretty easy. That kind of network latency happens all the time. And then everything goes wrong, services start falling over. That's a sign that you have a lot of issues to fix and that you've been relying on luck so far, right? So it requires kind of an audit to say where your safety system is right now relative to the amount that you've built. If things are good, continue on growth. If things are progressing very quickly, but any kind of fire drill shows that you have cascading failures, you have systems that depend on each other, one thing takes down 5 other services, I mean, at that point, it's like, if you continue growing, what happens if in a week, in a month, you have a major system outage? How much does that affect you? As your team, as your company, as your product, how much does that affect you? If that's a risk that you can take, then you can continue growing. But if you having an outage means that as a new service, no one is going to rely on you anymore, or as a big service, so many people are relying on you that you take down a third of the internet when that happens, then that is where that risk factor comes in. That is that potential for risk, the likelihood that it's going to happen versus how bad is this going to hurt you. And that's how you make that judgment. So you run the fire drills to see where you are, and then you can make a good management decision on more in this way or more in that way. And that's something that you can take up to. It's very hard, I think, to push for safety, to repair technical debt, to build documentation, to do that training when you have a lot of pressure to release new features, to go these deadlines. But if you have something to prove it, if you can say, look, we ran this test, a simple failure like increased packet loss will cause us to have a 4-hour outage. We need to take this time. That gives you something solid to say, this is why we need to do this. Okay? All right. Thank you very much.